Welcome to Standard Bots. Let's go see some things. Standard Bots is America's largest maker of AI-native industrial robots. We're making robots that are easier to program and more capable so they can do jobs that other robots just can't automate.
Do you know how many robots were installed worldwide last year, industrial robots? 500,000, right around there, 500,000 are the last official figures. A majority in China, 300,000. The US, a little bit over 30,000. That's pathetic. What's gonna happen is that's gonna go up like this now. And part of this, like companies like Standard Bots are doing that thing. First of all, they're bringing it back because we haven't really had American-built robots for a long time, and they're gonna make a dent in that supply. So this is 30 kilogram payload. This is a 2-meter reach, 66 pounds, 6 feet reach. Really, this is a robot, you can see it has payload on there. This is a robot that the market had a need for. They just didn't really exist in quite this long and quite this payload, 360 each way. Yeah.
But you can run it without an area scanner or a guarding if you do a risk assessment, and so it's collaborative as well. So it's maybe one of the biggest collaborative robots in the world.
Why is it doing these reps? I've been here for an hour kind of watching it work. What's the process like? What's this, what is it trying to simulate here?
Here it's running through a test cycle. So we run it for a couple of days. We make sure that everything works great. You'll be able to graph all kinds of signals from the robot to see that it's built as it should be before it goes out the door.
Very cool. And what's an example of what this would be doing in the real world? Lifting heavy machinery, pipes, like what does a robot this big do?
So it can move cases, for some of the biggest packaging companies in the world, can move tires, so it can move like big truck tires. It can, sometimes you just need a lot of reach. So if you have to go 6 feet out for something, and the beauty of what we've built is we've really built a platform so you can actually extend the tube between the joints, and you can make a longer arm with a little bit less payload or a shorter arm with more payload. So this is our kind of nominal size here, but
And it can also reach below the ground, right?
yeah.
So if we put that up on a shelf, we've got phenomenal reach way up here.
Yeah, that's right.
And then a lot of good reach even way down there.
Yeah. I think it is a rare moment of consensus where there's agreement that we need to lead in robotics, that it is a foundational technology, that we have to make robots here. We need American robots in American factories. I think you have a lot of labs doing a lot of research, and it's all very theoretical right now. We're taking this research and we're bringing it to the real world. And so we've chased down those problems, and I think we're the leader in building an amazing robot arm, and taking the latest in technology and AI, creating a human interface where anybody can pick it up and use it and train an AI model and deploy these things. And so we think that's what our country needs, and that's how we're going to deploy robots to every business. That's how we're going to dominate manufacturing. That's how we're going to build the biggest robotics company in the world. Let's check out an assembly station.
Yes.
This is where folks assemble the robots. So we've designed almost all the parts for our robot in-house here. So we have 2 TVs. One has all the tests that we run. So as you're building up the joint, you can see it spinning right now. So operators are able to test the product, see if it's been assembled correctly. A lot of diagnostics are run. We can graph everything, log it. The other TV runs our MES software. So we can track what parts were used, how many parts were used, how many we have in stock, and can
Exactly, have I
replenish.
run out, exactly,
Yeah.
for the replenishment. You need to know what's been used.
So the product that builds the product is the product too. And we refine this quite a bit, and we iterate on our software, and we make it better over time, really iterating to the point where we can just go copy paste, boom,
Right.
and we scale, hyperspeed.
Yeah.
So that's the idea here.
And exactly. And of course, these things are built to be ergonomic, so you know exactly what tools are needed, what parts are going to be there.
That's
it's very
right.
easy to grab something and go down there, so not only trying to fish something out.
Exactly. You don't want to have you want to have your incoming, your outgoing, you build it, done, next part. What we realized is if you want to have robots everywhere, in every home and every business, you have to make them so a mere mortal can deploy them. It can't just be experts. You have to make it so that an average factory worker can pick up the tablet and set up the robot and program it and use it. And so we saw a huge opportunity there. And then we realized with end-to-end AI now, if you looked a couple years ago, you would go and visit a researcher in robotics and they would spend 30 years trying to teach the robot how to fold clothes or something like that. And you look at it and you go, I don't know. And now with all the advancements that are happening with LLMs and elsewhere, it's all coming to the physical world. It's coming really quickly. We can demonstrate tasks to the robot and you can perform them. In our summer software release, we're showing our first implementation of few-shot learning. And so we're gonna have the ability to show a robot in just a couple demonstrations how to do a task, and the robot's going to be able to do it from those demonstrations. And so we're really excited about that.
What do we have here in the red room?
This is our welding solution. So
Okay.
we've built a package where a customer can weld really easily. They don't have to figure out what to buy. We just make it dead simple. And I don't think any other robot manufacturers ship something this simple for welding, where you can just pick it up and weld, and it's so simple and easy. We're obviously layering AI onto this, just like we do with everything we build, to make it really easy to inspect your welds, and soon you'll be able to use AI to do adaptive welding.
The workflow would be that an operator would put something in here that they need to have welded. They'd put it into the jig.
Yep.
And then they would just, how would they demonstrate it? Would they just kind of move it through and teach a couple of points?
You can use all of our teleoperation methods to demonstrate that we use for end-to-end AI, but you could also hold
So
the
you can
button,
grab it, right.
move the
So
robot
I can do with a
around.
teach pen where I can start moving it around until it kind of looks right, or I can
Yeah.
go ahead and grab it and say, that's where I want it to be.
Yeah.
Store the location, move it with a linear move in a certain direction until I get to the other position, say, store that, now
That's
I
right.
have it. And then of course you have your approaches and retracts and all those things to set up.
Yeah, that's right.
As well as any dwell times, arc on, arc off. Can I do something like if I have a weld like this, say I put it into a stitch mode? So I start here, start there, and break it up automatically?
Yeah, we can do stitching too.
Oh, okay.
Yeah, so we
Great,
try to
great.
make all that pretty simple. You don't have to be, I mean, eventually where we're going with this is just like we're going for everything else. We want to train an AI model that is as good as welding as that expert in your shop.
Right.
He knows how to weld anything. You put it, if you know bigger gap, like knows exact weld settings on the torch, there's not a lot of experimentation needed. And so if you had an AI model like that, right now welding is a lot of experimenting. Because you're kind of like eyeballing the thermal mass of the part and how many passes and what speed should I go. And you have to run a couple parts and you waste those parts to test. So we think this would be completely game changing, and that's the direction we're moving with all our products. Putting more AI in so that it's smarter, it's easier to set up, it's easier to run. You don't have to be an expert.
Yeah.
One analogy I like to make is that industrial arms and cobots kind of are like the GPUs of industrial labor, right? They're very multifaceted. They can
Yeah.
adapt to a variety of situations
Yeah,
compared
it's a good
to something like an
analogy,
ASIC, right? Which is built for just one specific application.
I like to think of it as a computer. And I think you and I agree on this, that right now is like 1972 for the computer industry. We're right at the beginning of this fundamental shift.
A common question I get asked is, how soon is all of this going to happen where robots become, as smart as humans and they can start doing almost every single task that you would ask of them?
I think that we're going to solve the factory in the fairly near future, where we're going to have the capability, and then it's a matter of turning it into a product, and that's where we plan on leading. So bringing the capability of the frontier models and having our own frontier model and deploying that and making that easy to deploy. But I think you're going to see within a few years, robots can do nearly anything that you throw at them.